Hello, so this is the first video for our new editing style. Please leave a comment on our video if you have any questions and don't forget to subscribe to our channel. Trigonometry is constantly around us and it originates from what some say would be the Babylon period or even earlier. However, I'm not here to talk about history, so we just discuss on the basics and I'll show some real-life examples of it. Right, so I'm sure many of you have heard of Pythagoras' theorem, but did you know that it was discovered while Pythagoras was in the toilet? Well, at least that's what my teacher used to say. So you know back then, floor tilings were made of squares and triangles like this. And what he discovered was that if you count the number of triangles in say square A and sum it up with the number of triangles in square B, you will get the same number of triangles in the big square C. And essentially that is how he came up with the idea of Pythagoras' theorem, where the sum of squared A, which is the area of A, and the area of B together is equivalent to the sum of C squared. And if you apply this onto most of the right angle triangle you see in this world, you can see that this theory actually holds. And one of the use of Pythagoras' theorem is used to find an unknown length when it comes to a right angle triangle. So say I want to find B, and all I have is the length of C and A, which are random constant. Therefore, if I substitute the lengths into the formula, I can easily find the length of A through basic algebra. Not only that, I also can get the unknown angle through the use of the shortcut SOHCAHTOA, which basically means that if I have, for example, for sine theta, I have the opposite length and I have the hypotenuse. All I need to do is to sub the constant into opposite and hypotenuse, and by using arc sine, I can find theta, which is the unknown angle. And you can determine the opposite, by which it is the opposite line of your angle, and adjacent, which is the line adjacent to your angle, together with hypotenuse, which essentially is the longest length of your right angle triangle. As such, as long as I have two lengths, I can find the remaining length and angle. So for example, I want to break into the house, and unfortunately it is surrounded by a sea full of sharks. And due to our past experience, I know that I have to break the window in order to get into the house. From what I get now, it looks like I have a right angle triangle for where I'm positioned at, and the window. There. So we know that the window is 20 meters from the ground. How we know? Let's not get too much into that. But let's just say I've been there and tried some things. But we know what we know, okay? And we know that we are 30 meters away from the house, because that's what my restraining order says. Now we're not going to talk about why I have a restraining order, but I do have one that tells me that I'm only allowed 30 meters away from the house. So with that information, let's take a look about how we can calculate the angle at which we can throw the rock at. So remember the SOHCAHTOA rule. We know that an angle can be found by substituting the opposite length over the adjacent length to get our unknown. So by using arctan 2/3 or 20/3, we get 0.588 radians, which can be converted to degrees if we divide radian over pi multiplied by 180 degrees. So there you have it. I need to throw the rock at a 33.7 degree, assuming that the rock moves linearly, of course. And bam! Now, I'm obviously not going to swim there because there's shark. I'll just get a ladder. But how long should I get the ladder to be in order for me to get across? Now I'm definitely not going through the door because I've already broken the window and I gotta use it now, you know. So back to a triangle. Now I need to find the length, and thanks to Pythagoras, we can solve this question easily. So by substituting 20 and 30 into A and B, we get C squared. Now I could take C squared, but it will just make no sense. So I'll just square root it, and now we have 10 so 13 meters. So I need a ladder that is 10 so 13 long. Right? Done. And yep, this is my house now. So that's one of the examples when it comes to using trigonometry to find lengths and angles. But of course, there is more to it that you need to cover for your exams. So for example, being able to draw different graphs with or without a constraint, and understanding the factors that can change how the graph looks, such as amplitude, frequency, and even how the graph shifts from the original, which is C by the way. So do revise if you have no idea what I'm talking about, and if you have questions, our Discord is always open, is always available, and don't forget to subscribe. Thank you.